Alright, so in this question here, anaerobic capacity, once again we've got a function. I'm going to call this E of t. So we're looking at the anaerobic capacity. Initially, show that k equals 0.1. That's just going to be a solve, and then we're going to go through that now. Once again, all this is tech active, so we're going to go through the whole thing with Kaz. So over here, we're going to say, whoops, where's Kaz? Here's Kaz. So I'm going to close this. No, I'm going to go to this. I'm going to say define E of t equals 20 plus 160, 20, whoops, 20 plus 160 times 2 to the power of negative k times t. I'm going to put in our times there. Given that t is equal to or greater than 0. Equal to or greater than 0. That's what we've got there. So what is her anaerobic capacity initially? We'll say E of 0, 180, and that makes sense. If we set this to 0, 2 to the power of 2 to the power of 0 ends up being 1. 160 times 160 plus 20 gives 180. Okay, so show that k equals 0.1. So after 10 minutes of activity, she commences after capacity at 10 minutes after she commences is 100 joules. Okay, so that means we're setting this to 100. So I want that to t to 10. So I'll say solve E of 10 equals 100 for k, and there we go. So we'd have that. Well, we'd write down this, and instead of 10 with t, we'd put 10 equals 100, and then k gives us the answer. Okay, from there we want to find the average rate of change of her anaerobic capacity between 20 and 10. So that means we've got to do our f of our 20 and 40. So we'll say E, we're going to do some division. We're going to say divide by, so we're going to say E of 40 minus E of 20 divided by 40 minus 20. So this is y2 minus y1 over x2 minus x1. And then close that, see if it works. No, that looks terrible. So we've got to do that again. Divided by, so here we'll say E of 40 minus E of 20. Now just try 40 minus 20. 40 minus 20. We'll just try to make it over 20 because we know 40 minus 20 is 20. There we go. So that's what we end up with there. That's no good. Oh no, we've got to change the value of k. K is 0.1. So let's define the function again. Set k to 0.1. And now we'll go through this again. It's negative 1.5, so that's the average rate of change. So that's the type of thing you need. So you'd be writing this minus this over this to give you negative 1.5. Over time, what does her anaerobic capacity approach? So what we're doing is we're looking at, as time goes on, what does it approach? So let's choose a so that would end up approaching 20 because that's what our asymptote there is. So this is our anaerobic capacity. If we graphed it, let's graph it. I know we've got to write that as a function of x now. So define E of x as this. I'm going to graph that E of x, and if we scroll up, oh no, it's not there. Maybe it's going to approach 180. Menu, window settings, -2, let's go up to 60, -5, let's go to 200. Oh, there we go. So what's it approaching? No, it is approaching 20, I'd say. Tab 20. Yeah, there it is. So yeah, it is approaching 20. Okay, so that's that question done. Okay, we won't worry about this question for now. I've got to try and really sort a few things out there. This question. So that's it. We'll have a look at those two questions and that'll do.